What's up, guys? Just back in my house, the Mustang behind me. Today we're going to be installing the single plane intake manifold on the 351 Cleveland. After that, we're going to be finishing up the alternator and water pump pulleys and brackets, and hopefully getting some more progress on the way to finishing that cam swap. What's up, guys? Right here, I got an Edelbrock Torker intake manifold for 351 Cleveland. I bought this from a gentleman down in San Jose by the name of Vince, who'd had it in storage for, he said, over 30 years. And it came with the vacuum secondaries Holly, which I removed. And it originally had the cloverleaf pattern, which, as I understand in the instructions originally for this manifold, was included for street driving and recommended to be removed for drag racing. Now, I have plans to run this intake manifold with a Predator 6000 carburetor. And for those who don't know, the Predator is a variable Venturi design, and the Venturi of that carburetor is square, as opposed to being 4 round holes for Holly or an Edelbrock. So a square Venturi design would not work with that cloverleaf, street driving or drag racing notwithstanding. Although this build, this intake, is definitely intended for the more high performance street application. So that being said, I decided to mill out the cloverleaf to give this a straight shot into the plenum. I lined up the carburetor gasket and used Sharpie to mark out the area that I would remove. Using this end mill on this manual milling machine, I removed that material, and the result is actually quite nice, as you'll see shortly. Now, upon closer inspection of this intake, you can see why I chose to use this end mill, as it very closely fits the radius of the corners of that cloverleaf, which allowed me to very carefully remove only the material that was necessary. Now, all 4 of these bolt holes for the carburetor studs had the threads basically completely stripped out. So that being said, I decided to drill and tap those to a larger size, machine an aluminum plug and install that, and tighten that down so it bottoms out on the bottom of that new bolt hole, and then using TIG welder, weld over the top of those plugs, and then putting it back on the milling machine using the same end mill, milled the top of this carburetor flange flat. What that did is remove the excess weld on top of those plugs, as well as true up this carburetor flange surface. Once that was done, using the carburetor gasket for reference, I drilled and tapped all 4 of these holes back to 5/16, which worked quite well. And this is the first time that I tried a repair like this, and I'm very happy with the result. And you add a little chamfer on each of the holes when you're done. Now, after completing that job, flip the manifold over to where originally there is a heat crossover for the exhaust gases on both sides of this intake. So what that's for is to allow a street car to warm up faster and run better when it's cold, to give a little bit of heat in the intake. For a high performance application, we don't want that. We want our intake charged as cool as possible. And therefore, we TIG welded that hole closed and grinded off the excess weld to make that flat. Do that on both sides, and that's quite an easy and long-term solution to this performance limiting feature on this manifold. It's much more bulletproof and reliable than, say, a piece of beer can in your intake gasket, or some of those corrugated metal plugs that they include in the intake gasket sets. So one more important point to make about doing a job like this on an intake manifold, whether you're removing the cloverleaf pattern or you're just trying to true up the carburetor flange. Really any job where you're going to be putting an intake manifold onto a milling machine. Now, keep in mind, you really do need access to a milling machine for this job. Drill press, hand drill, any other idea you might come up with to try and make this work, those tools really aren't capable for this. So for most people at home, you're probably going to end up with sending this out to your local trusted machine shop and having them do this for you. This is not a hard job for a professional and likely wouldn't cost you very much. But if you're like me, wanted to learn, wanted to do this yourself, there's a very important aspect to this job that one needs to keep in mind, which is the level of the carburetor flange is not at the same angle as the base of the intake. That's because the engine slanted back in the car, and the level of the carburetor flange is offset to that to allow the carburetor to sit level. Now, when you clamp this down onto the milling machine table with clamps on each corner, you're going to need to put parallels under the low side to bring it up to match the higher side so the carburetor flange is level. Now what I did is I clamped a dial indicator to the quill of the milling machine and ran that over the carburetor flange surface. And that gave me an initial idea of how true this was, as well as allowed me to dial in my parallels to make this surface level. And that's a very important step to do here, and you want to be as accurate as possible so you're not indiscriminately removing material and you end up with a crooked carburetor when you're done with this. It will be very easy to see when you bolt your intake down onto your engine. You're all excited to put your new Holly double pumper or a Predator even, and you end up with your carburetor either tilted way far back or off to the side. All right guys, now we're back at the house. Got this intake manifold here on the desk and we're ready to install it on the car. This little 1/8 inch aluminum plate that I made is going to cover up the opening for the choke stove that would lead to the heat crossovers that we blocked off. We're running an electric choke right now and probably no choke in the future, so this is not going to be necessary. We're going to be using this intake manifold gasket set from Mr. Gasket. It has this silicone bead around each of the intake ports. After developing an intake leak on this engine, which is what led me to remove the intake and discover our failed lifter, I wanted to pursue a different style of intake gasket. I was considering running a standard paper gasket and laying a bead of silicone out of a tube around the intake ports, but I like this style and I'm confident this is going to work well. We're not going to be using the cork end seals. We're going to be laying a bead of black silicone on the china walls, and we're going to be using the spray adhesive to lock these gaskets down so they don't slide when we drop down our intake. All right, now we got our intake gaskets glued to the cylinder heads and about a 1/4 inch bead of silicone laid on the china walls. Let that tack up for about 5 minutes. So now it's time to drop the intake on, make sure everything's lined up carefully, and start tightening our bolts. Per the instructions from Edelbrock, they say to lubricate the threads with motor oil, no sealer. There's no coolant in the intake on these engines. I don't have any motor oil on hand. I'm just going to use a little ATF on the threads to ensure we get a proper torque reading. All right, we got our gaskets lined up perfectly. Now we can drop the manifold down, and that coverage of the silicone bead is quite good, I think. Those bolt holes look perfect. Looks like there's plenty of silicone. Ports look good. Well, I'm happy with that. Let's get some bolts in it. Now we got our intake on. At the end of the day and 2 trips to the hardware store, this intake needed bolts of 5 different lengths. Right now, I'm running a 750 vacuum secondaries quick fuel carburetor. We also got the oil pan on. So the motor's almost back together. Got to connect a fuel line, some electrical. We got to fill it with oil and install the distributor and set our initial timing so the engine will fire up right away. I want to give a shout out to Melvin Hanning for kindly sending me a set of oil deflectors for the rocker arms. I appreciate your generosity, Melvin. If you're anything like me and enjoy screwing around with cars, I know you'll understand my excitement when it comes to firing this baby up and hearing her make some noise.